Alright, you guys, so we're going to go ahead and go over problem 16 and on in this case 16 and on. Now, in this case, 16 and 17 actually focuses on those special right triangles in this case. The special right triangles would actually be these ones here, where in this case we have a 45, 45, 90 triangle, and then we also have a 30, 60, 90 triangle. All right, so in this case we are going to be focusing on these here, guys. Once again, we are starting off in this case with the 45, 45, 90 triangle. So if we're given, for example, this side here, which is x, that would be the side that's opposite to the 45. As well, if they're just giving us one single angle, we could actually determine the other angle by doing 180 minus 90 and minus 45. And we determine that this here is also 45. All right. So basically the 45, 45, 90 triangle is like an isosceles triangle, where in this case you have this side equal to that side, right? So let's go ahead and get started, guys. There's actually two of them here. I'm actually going to go ahead and focus on the second one here. And in this case, we have, once again, a 45-degree here, which in this case, we can assume that this is also going to be a 45 degrees, all right? Now, in this case, once again, we want to go ahead and actually solve for x. We want to go ahead and know what x is, right? Now, in this case, x, which is opposite to that 45, in this case up here, I did show it off as x, but I'm just going to go ahead and label this as n. I know when we did this in our notes, I had this labeled as n. Now, if we take a look at the side that we're given, we're actually given the 12, and the 12 is actually opposite to that 90-degree angle. If we take a look at this one here, the side that is opposite to a 90-degree would be x squared root of 2, or in this case, I'm going to go ahead and actually use n squared root of 2. All right, we're going to go ahead and erase that. Goal in this case, guys, is to actually solve for n. If we solve for n, we're actually able to solve for x as well, because that's the value of x. So in order for us to actually do that, I'm actually going to be dividing both sides by the square root of 2 and dividing both sides by the square root of 2. This cancels out of the left-hand side, and we have n is equal to 12 over square root of 2. Now, because we do have a radical on the bottom of the fraction, the denominator, we are going to get rid of it. The only way for us to actually get rid of a square root in this case, is doing the opposite, which is squaring it. And if you square it, it's actually multiplying it by itself. So I'm going to go ahead and multiply it by itself on top and bottom. Top and bottom. So that's going to give us n equals 12 square root of 2. Now, square root of 2 times the square root of 2 in this case would give us square root of 4. If we simplify that, that is 2. From there, we can't really consider this our answer because we still can simplify these two. So we're going to go ahead and divide both of those by a 2. So our final answer in this case should actually be 6 square root of 2. So in this case, x over here equals 6 square root of 2. And that would be for this triangle here. So that is our work, and this is actually what x would equal as well. Now, try to apply, in this case, the same methods in this case, or similar methods, onto this one here. All right. Now, let's go ahead and move on to the next one, guys, on 17. And in this case, we do have two triangles here. We have a 30, 60, 90 triangle on each of them. So we want to go ahead, in this case, determine the missing side. All right. So for example, on this here, we are going to be finding all missing sides. And I believe that was actually the same thing we had to do up here, find all missing sides. This other side in this case, guys, would actually also be x, which is a 6 square root of 2. So then we found all sides here. All right. So in this case, guys, we do have to find all sides. So I'm actually going to go ahead and focus on the harder one. And the harder one in this case would be this one, just because we see a square root somewhere in our answer here, in our given terms, right? So to start off in this case, guys, we have that 30 degrees. We have this one, in this case, being our 60 degrees. So going back to this identity once again, the angles that are across the 30 degrees represent the x. That actually represents the x for us, which means that whatever that equals, I could actually input it here to find the side that's opposite to the 60, and then I could multiply by 2 to determine the side that is opposite to the 90 degrees. So, in this case, once again, this side is the one that is opposite to the 30 degrees, all right? Now, the side that is opposite to the 90 degrees should be equal to n, not n equals, but n square root of 3. And then the side that is opposite to our 90 degrees in this case should be actually 2n. Now, because we have 6 square root of 2, that is actually already equal to n. So this here, where am I? Sorry about that. This here is already n. So let's just go ahead and do basic multiplication here. If we start off at the top in this case, I would have 2 times 6 square root of 2. 2 times 6 is 12, and that gives us 12 square root of 2. So in this case, AB is equal to 12 square root of 2. Now let's go ahead and take a look at the next one. The next one in this case here on the bottom, I should have 6 square root of 2 times square root of 3. Because we have 2 square roots in this case, guys, we're actually going to go ahead and multiply the insides radicand. So that's going to be 6. And that would actually be the answer for side AC. Side AC. And in this case, we actually found all of our sides. All of our sides here. Okay. So try to apply in this case same method, guys, on the next problem that is found in the same example here. Now let's go ahead and take a look. Let me just come back here just in case you guys need it. But in this case, let's go ahead and take a look at the next one. In this case, it says that each vertical cross section here of the triangular prism shown below is an isosceles triangle. It says, what is the slant height of S in the triangular prism? Round the answer to the nearest tenth. So we want to go ahead and actually find our slanted height, right? So the first thing we want to go ahead and identify is what we're looking for. We're looking for this here, the slanted height, right? Now, in order for us to do this, most of the time we do have to focus on probably finding a right triangle that we could use so that we could apply Pythagorean theorem on this here. So notice in this case, I actually do have a triangle, and I'll go ahead and go over it here. That would actually be the height, and that would be one of the measurements, right? So this here is 90 degrees as well. Now, the whole thing here is 4. I'm actually only taking half of it, so half of that would actually make it 2. So in this case, we have a triangle that has S as one of the sides. It has the height at 5, and then the other side to be 2. All right, now because we're using Pythagorean theorem in this case, guys, we do have an a squared plus a b squared equals a c squared. So easiest one to identify in this case, guys, is c, because that's the side that's opposite to our 90 degree. And then in this case, a and b could actually be any of the other two sides. So we'll go ahead and do 2 squared plus 5 squared equals s squared. 2 squared in this case, guys, is 4 plus 5 squared is 25 equals s squared. It's going to give us 29 equal to s squared. The only way for us to actually get rid of the squared and solve for s is to take the square root, do the opposite here. So s in this case is supposed to equal the square root of 29. Or if we actually want to go ahead and round this off, square root of, sorry about that, square root of 29, we get 5 point, what was our decimal place value? Nearest tenth. So 1 decimal place, 5.4. And that would be our answer.